we have come onto a new page for the proof of Archimedes' principle, which is also here on your screen on right hand side. The buoyant force on an immersed body has the same magnitude as the weight of the fluid displaced by the body. And we shall go for both theoretical and experimental proof of this statement. But first of all, we shall go for the theoretical proof. For this, let us take a tall vessel filled up to a mark with a fluid. Well, this is a liquid shown here, but it can be a fluid, right? And suppose the density of this fluid is rho f, and we shall take this immersed body to be a body of regular shape, that is a rectangular block here. It will be convenient to deal with this. This rectangular block is completely immersed inside the fluid at some depth below the free surface. Let me name this rectangular block as ABCD, the front vertical face, and then EFGH, the back side vertical face. I show the dimensions of this block. Try to follow my writing. This is L, the length is L, width is W, and height is equal to H. Further, suppose the top horizontal face, that is AHGB, is at a depth of H1 below the free surface, and the bottom horizontal face, that is DEFC, is at a depth of H2 below the free surface. This I also show in my figure. The smaller depth is H1 of the top face, and the larger depth is H2 for the bottom face. So the question is, what are the forces acting on the 6 bounding surfaces of this immersed rectangular block? As you are aware, pressure is exerted by the fluid normally onto the surface at every point. We can consider the vertical faces first. Let us take the front and the back vertical faces, that is A, B, C, D and E, F, G, H. As you go from the top to the bottom of either of these two vertical faces, pressure increases with depth, but the variation of pressure follows the same pattern for either the front vertical face or the back side vertical face. And similarly also for the other two vertical faces, is the right side vertical face BGFC, left side vertical face AHED. So I repeat once again, there are 4 vertical faces, this one, they are the front and the back side vertical faces, and then this one and this one, they are the left and right vertical faces, and all of them pressure increases gradually from the lowest value here to the maximum value here. The variation is linear and follows same pattern for all 4 vertical faces. So I can conclude that on opposite vertical faces, the thrust due to the fluid will have the same magnitude, opposite directions, and the same line of action, and therefore they will cancel each other out. So let me show that. Consider this front vertical face. On this, force of pressure is this one, acting normally onto the face. Similarly, on the back side vertical face, that is HGFE, the force of pressure acting equal magnitude opposite direction. This some portion of this arrow is shown in dashed line because in a front view you can only see part of this vector arrow, isn't it, for this arrangement. So these two forces cancel each other out on the front and the back side vertical faces. Next, consider the left and the right vertical faces. Once again, on the right vertical face, force of pressure acting to the left horizontally, and on the left vertical face, that is AHED, the force of pressure acting normally to the right, and therefore these two forces have same magnitude, opposite direction, same line of action, they cancel each other out. So you see that the force of pressure on the four vertical faces cancel each other out. But can we say the same thing about the force of pressure on the top and the bottom horizontal faces? The answer is no, because of the simple reason that the depths of these two faces are different.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.